Hi everyone, thank you so much for coming to this video. So today we're going to be going over trig proofs. So make sure you review the lessons on trig identities and functions, as that will come into a lot of use for this video. So like always, there's going to be timestamps in the description of the video, so you can feel free to skip to any parts you want to. The learning objective for today is going to be able to construct proofs involving trigonometric functions and identities. Because we've already learned what the trig identity is, we're just going to be going over 2 exam questions, so just so you understand how you can apply these for proof questions. So let's get started. So I have an exam question here. Again, feel free to pause the video and try it out for yourself first, using everything that we've learned previously. So the first part is we want to prove that tan theta plus cot theta is equal to 2 cosec 2 theta. So the first thing you want to do is we want to see, maybe we can rewrite what 2 cosec 2 theta is in another way, so we know another form that we want to get to. It just may make our life a bit easier. So if you do this from the side, we could have that cosec 2 theta. If you remember that cosec theta is just 1 over sine theta, so this would just be 1 over sine 2 theta. Then if you remember double angle formulae, this is just equal to 1 over 2 sine theta cos theta. So now we have an idea of different forms that we want to try and aim to. Let's see if we can do that. So for part I, so we have tan theta plus cot theta. So is there any way that we can write this in terms of sine and cos? Because we know that we want to have sine and cos in our final answer. So yeah, if you remember that, if I write this again here, if you remember that tan x is just equal to sine x over cos x, then we can rewrite tan theta as just sine theta over cos theta. And then you know that cot theta is just the reciprocal of tan theta. So cot theta is just 1 over tan theta. So you just flip this around. So you can write that's just the same as cos theta over sine theta. And now, so now you can, if you notice that if we multiply this out, like cross multiply to find a common denominator, we would get sine theta cos theta, which is really similar to what we want over here. So let's try that. So if we do sine squared theta, and then if you multiply cos theta by this, we get plus cos squared theta, and that will all be over sine theta cos theta. And now, if we remember the identity of sine squared theta plus cos squared theta, that's just equal to 1 over sine theta cos theta. And then if we just multiply both bottom and top by 2, so we just get 2 over 2. So if you multiply both top and bottom by 2, that's just the same as multiplying it by 1. That would just be equal to 2 over 2 sine theta cos theta, which that's just the same as 2 over, that's just the same as, 2 cosec 2 theta from over here. So that's your solution to the first question. So the key for this one was just to rewrite cosec 2 theta in another form, as that kind of just helps you guide in the direction to how you're going to prove the whole question, and then just using what the final solution is and using some other identities that we've learned about tan, and then also about sine squared theta plus cos squared theta is just equal to 1. And then and then if you just multiply top and bottom by 2, it's just the same as multiplying top and bottom by 1, so it's not actually changing the value of your function, then you would get your final answer as 2 cosec 2 theta. So then the last bit is we want to explain why the equation tan theta plus cot theta is equal to 1. So if we know that tan theta plus cot theta, that's just equal to 2 cosec 2 theta. And then we know that that's just the same as 2 over sine 2 theta. So if you want that to be equal to 1, so if we cross multiply, that means we'll get 2 is equal to sine 2 theta. And now if you remember the graph for sine theta, then it'll just go like this, with this being 180 and this being 360. And this being 1 and this being 2. And then for sine 2 theta, you just want to squash it by a half in the horizontal axis. So it would now go through 90, this will go through 180, so it'll still pass at 1, so it will only change like this. So this should be -1. So yeah, it never reaches, the sine 2 theta graph is still between 1 and -1, like the sine theta graph, because you're not stretching it in the vertical direction in any way. So that means there's never going to be any values for when sine 2 theta would equal 2. So therefore that means that tan theta plus cot theta equals 1 will also have no real solutions. So yeah, that's the answer to this first question. Now let's move on to our second one. Okay, so moving on to the next question. Feel free to pause the video and try it out for yourself first. So we want to prove that 1 over sine 2 theta minus cos 2 theta over sine 2 theta is equal to tan theta. So the first thing you want to notice that we have a common denominator here, so we can just rewrite that as saying 1 minus cos 2 theta over sine 2 theta. And now we want to remember our double angle formulae. So if you remember that cos 2 theta, that's just equal to cos squared theta minus sine squared theta. And because we know that tan theta is just sine theta over cos theta, it'll be helpful if we have the whole of the numerator in terms of sine theta, as that's what tan theta is. So we can rewrite this as being 1 minus sine squared theta minus sine squared theta, because that is, remember that sine squared theta plus cos squared theta is just equal to 1. So that's just equal to 1 minus 2 sine squared theta. So if you write that, that's just equal to 1 minus 2 sine squared theta. Then if you remember sine 2 theta, that's equal to 2 sine theta cos theta. So that's all over 2 sine theta cos theta. So then if we rearrange this, simplify it, we'll get 2 sine squared theta all over sine theta cos theta multiplied by 2, and then we can just cancel out 2, and then we can cancel out a sine here, and then you're just left with sine theta over cos theta, and that's just the same as tan theta, and that's your answer to this. So this one, the key was just to remembering your double angle formulae and which one would be the most useful for the cos 2 theta. So if you remember that tan theta is just sine theta over cos theta, we want to try and get your whole numerator in terms of sine theta. So using this formula type would probably be the most useful, and then using that you can just simplify to tan theta. But remember, let's say you didn't get this and you use the other one, then and if that didn't work, then just keep trying, like try again until you get your final answer there. So that was the answer to this question. So that's everything. Hopefully you found this useful. So just to sum up, we went through how to construct proofs involving trig functions and identities. So in order to master this, it just takes a lot of practice. So make sure you do loads of practice questions and make sure you fully understand how to use all the trig identities and like double angle formulae we went through before. But other than that, thank you.